Hi, this is Kelly. I'm going to discuss the first question of static assignment. So in this question, we are going to define the force member KL, PQ, FH, EJ, and DS of a transmission line tower. So as the question just asked about the specific force members, so we're going to use the method of section to find the value. But before we start, since the dimension of this diagram are not complete, so we're going to assume all the missing dimension and angle. So let's start with force member KL and force member PQ. So first up, we cut the truss at this position and we draw a free body diagram of section. So by referring to this free body diagram, we found that point Q has joined two forces. So by using moment at point Q, we can eliminate these two forces and we can find FKL equals to 50.4 kN. While finding FPQ, we use moment at point L to eliminate these two forces and we find FPQ equals to negative 43.75 kN. Next, we'll find force member FH. So by cutting a truss at this position, we draw a free body diagram here. So in this situation, we cannot find a point that meet two other forces and help us to eliminate them. So we need to find value of FHI first by using moment at point F. So we get FHI equals to 40 kN. Then we use summation of Fx equals to 0 and summation Fy equal to 0 to create two equations. Then we substitute the value of FHI into it. Then using calculator, we can find that FH equals to 43.3 kN. Next, we find the value of FEJ. So by cutting the truss at this position, we draw a free body diagram first. And by observing the diagram, we can find that the diagram is symmetrical. So FJK is equal to FKL. And since we already have the value of FKL, so we know that FJK equals to 50.4 kN. Then by referring to the free body diagram, FEJ is only at the x-axis. So to eliminate it, we can use summation Fy equals to 0 to find value of FEJ. Then we get FEJ equals to 0.244 kN. Last, we find the force member DS. So first step, we draw a free body diagram of section first. And we can see this is a similar situation with the previous one when we find the force member FH. So we need to find FDC first by using moment at point S. We get FDC equals to negative 25.32 kN. Then by using summation Fx equals to 0 and summation Fy equals to 0, we create two equations. We substitute the value of FDC into it. Then by using calculator, we can find FDS equals to negative 0.01 kN. And this is the end of question 1.
Okay, next. Here is second question. Second question asks us to find magnitude of the gripping force reducement to 300 Newton force like as shown here. To complete this question, we need to identify that this program machine. So when it machine, we need to separate the machine by part like this. Here we have three part to do. First part, second part, and third part. We need to resolve at the all joint that have. Here we have two joint, which is pin. So it have two forces. At C we have Cy and Cx, and at 1A we have Ax and Ay. substitute. We use next we use equation fx equal to 0, and then substitute all the all the force ax minus cx equal to 0, and then we identify that ax equal to cx. Next we move to fy, which is we use the formula fy equal to 0, same step, and we got ay equal to cy. Last step we use moment at point A, and then substitute all the information, and then we got cx, simplify, and then we got cx. As you can see, cx equal to 2.8 cy, which is here, as we can see, it has to unknown. So we need to proceed to the next part. Same step, we need to resolve all the point for the joint that have. We first step, we need to find the moment at point D. The moment equal to 0, and then substitute all the forces like this, and then substitute 2.8 cy into cx that we have found before, and then substitute all the information on the value, and then we got cy. And then since we know that ay equal to cy, hence ay was the value of ay was equal to cy. And then to find the cy, to find the cx, we substitute the cy that we found to the equation that we have solved before, which is cx equal to 2.8 cy, and then substitute the value, we got the value. And then as we can see here, ax equal to cx, therefore the value of ax was same like the value of cx. Next, the last part, first step, we need to find the moment at point D, which is we use the formula moment equal to 0, and then substitute the value or the values. As you can see here, G stands for the gripping force. So when you substitute, you can get the value of G, which is gripping force. Next, we move on to the next question. This question, it asks us to find CD, force at CD, AB, FH, and PG. And it given 300 Newton load. With this, and here we separate by 3 parts. We use the method of section. First, we need to first step, we find the moment at point C. We use moment equal to 0, substitute all the value, and then we got FAB. To find the force at FCD and FCE, we use formula Fx equal to 0. But as you can see here, we don't have the angle to resolve it. But we use, to find the angle, we use formula tan alpha equal to 20 over 50, and alpha, we got alpha equal to 21.8. Same as beta. Here, to find beta, we use tan beta equal to 40 over 10, and we got beta. And then substitute the value to the formula fx equal to 0, and then we got equation FCD cos 21.8 plus FCE cos 75.96 equal to negative 750. And then proceed to the next step, which is we use Fy equal to 0, substitute use the same method, same step, and then we got this value. And then we got FCD equal to this one. Next part, first step, we need to find the angle. Here theta, tan theta equal to 17. over 75 over 75, and then we got theta equal to 45. Next step, we find the moment at point G, substitute all the values to the formula, and then we got FH equal to this one. And then we got the answer of force at FFH. Last one, we need to find the force by pin G, which is when we resolve point G have to axis gx and gy, and then use the same formula, same method, fx equal to 0, gx equal to 0, and then we find the fy equal to 0, gy minus 1,100 equal to 0, and then gy, we get the answer of gy, which is 1,500 Newton.
So now I'm going to explain about question number 4. So number 4, arm ABC is connected by pins to a collar at B and to crank CD at C. Neglecting the effect of friction, determine the couple M, forces at pin B, pin C, and support pin D. Required to hold the system in equilibrium when theta equals to 0 and theta equals to 90 degree. For case 1, we want to calculate when theta equals to 0. So for B, moment C equals to 0. So as we know, moment is force multiplied with perpendicular distance. 240 Newton multiplied with 500 minus By multiplied with 160 equals to 0. 160 By equals to 120,000, and By equals to 750 Newton. For C, we want to calculate forces at pin C. We use Fx equals to 0 and Fy equals to 0. For Fx equals to 0, negative 240 plus Cx equals to 0. Cx equals to 240 Newton. For Fy equals to 0, negative 750 plus Cy equals to 0. Cy equals to 750 Newton. Now, for A, we want to calculate the couple M. We use moment D equals to 0. So, negative 240 multiplied with 125 plus 750 multiplied with 300 plus M equals to 0. So, the total of negative 240 multiplied with 125 plus 750 multiplied with 300 is 195,000 plus M equals to 0. M is equals to negative 195,000 in Newton mm. Next, we want to calculate the support at pin D, forces support at pin D. So we use Fx equals to 0 and Fy equals to 0. For Fx equals to 0, dx minus with Cx equals to 0. Dx equals to Cx, and the total of dx is equals to 240 Newton. For Fy equals to 0, dy minus Cy equals to 0, dy equals to Cy, and the total of dy is equals to 750 Newton. For case 2, when theta equals to 90 degree. For question B, we want to calculate the forces at pin B. So we use moment C equals to 0. By multiplied with 160 minus 240 multiplied with 250 equals to 0. So the total is 160 by minus 60,000 equals to 0. To find by, we need to transfer negative 60,000 to the right hand side. So it be 160 by equals to 60,000. By equals to 375 Newton. For C, we want to calculate the forces at pin C. So we're going to use Fx equals to 0 and Fy equals to 0. For Fx equals to 0, we just need to take Cx equals to 0. For Fy equals to 0, negative 240 plus 375 minus Cy equals to 0. The total of Cy is 135 meters. Next, we're going to calculate the couple M. So we're going to use the moment D equals to 0. D minus 135 multiplied with 300 plus M equals to 0. So the total is negative 40500 plus M equals to 0. M is 40500 N Newton mm. For D, to calculate the support at pin D for theta 90 degree. So we use Fx equals to 0 and Fy equals to 0. For Fx equals to 0, we just put negative dx plus cx equals to 0 and dx equals to cx. dx equals to 0. For Fy equals to 0, cy minus dy equals to 0. dy equals to cy and dy, the total of dy is 135 Newton. Question 5. Two hydraulic cylinders control the position of the robotic arm ABC. Knowing that in the position shown the cylinders are parallel, determine the force exerted A by each cylinder, B force exerted by pin B, C force exerted at support F when P equals to 250 Newton and Q equals to 150 Newton. For A, we want to calculate the force exerted by each cylinder. So we use moment B equals to 0. We use trigonometry at force AE. 4 over 5 FAE multiplied with 150 minus 250 multiplied with 600 equals to 0. So it be 120 FAE minus 150,000 equals to 0. Force AE equals to 150,000 over 120. So the answer for force at AE is 1250 Newton. For B, we use moment C equals to 0 to calculate the force exerted by pin B. So we just use 1250 multiplies with 4 over 5 multiplies with 150 plus 600 minus Py times with 600 equals to 0. So next is 750,000 minus 600 Py equals to 0. By equals to 750,000 minus 600. The answer for By is 1250 Newton. Next we use Fx equals to 0. Negative 1 1250 multiplies with 3 over 5 plus bx minus 150 equals to 0. Bx equals to 150 plus 750. Bx equals to 900 Newton.
Then we'll find the value of FDG. Since we already know the value of By and Bx from the previous step, we can use moment at point F to find the value of FDG. And we get that FDG equals to negative 93.75 N. Then we can find the forces exerted at support F by using summation Fx equals to 0 and summation Fy equals to 0. We get Fx equals to 843.75 N and Fy equals to 1175 N. And this is the end of our static assignment discussion. Thank you.